All right, this is 11E notes on trig identities. So these are just statements that are true about using trig functions. And I'll show you how we're going to apply these in a moment. All right, the first ones we're going to look at are what we call the reciprocal identities. So sine of theta is equal to 1 over cosecant of theta. So that means cosecant of theta is 1 over sine of theta. Cosine of theta is 1 over secant theta. These are just equivalent expressions. We're going to be substituting them in for each other. Secant of theta is 1 over cosine of theta. And finally, tangent of theta is 1 over cotangent of theta. And cotangent of theta is 1 over tangent of theta. Reciprocal identities. All right. Next, we're going to look at what we call the quotient identities. All right. So remember in our unit circle, all right, this distance is our x, this distance is our y. So x is cosine of theta, y is sine of theta. So tangent, we know the definition of tangent is y over x. So that means it's equivalent to sine theta over cosine theta. All right, now you can't cross out those thetas, and that's a combined statement, sort of like having a binomial. You can't substitute or cross out part of it. And cotangent of theta is defined to be x over y, so that means the quotient identity is cosine theta over sine theta. All right, so those are the quotient identities. So you're going to have to memorize all these different identities. All right, next we're going to look at the Pythagorean identities. In the unit circle, our equation is x squared plus y squared equals 1 squared, which is 1. And we looked at in the previous slide the fact that x is cosine of theta and y is sine of theta in the unit circle. So if we just substituted in cosine of theta squared for x squared plus the sine squared of theta for y squared is equal to 1. That's going to make our first Pythagorean identity. Now notice where we're putting that square. We put it inside. It means cosine squared theta means cosine theta squared. But it's just a neater way to write it to pull that square inside that cosine. All right, so it's still just arithmetic-wise the cosine of theta times the cosine of theta. It's just like whoever decided to write, they decided that they liked the way it looked when that 2 was pulled in the cosine. The main reason is because, like I said, it's not just the theta being squared, it's the entire trig function being squared. All right, so there's just a little notation there. All right, so let's look at other forms of this. So you're not always going to see it in this order. So we can write the other forms of this. If I subtract cosine theta, so cosine squared theta from both sides, I'm going to end up with sine squared theta equals 1 minus cosine squared theta. That's another form of it. It's still the same identity, it's just the order is changed around. And I can turn around and do the same thing with my sine squared theta, and I'm going to get cosine squared theta is equal to 1 minus sine squared theta. It's just different forms, and you're going to have to recognize those when you see it. So just remember, when they're squared, cosine and sine go together. All right, so let's make 2 more Pythagorean identities. Identity number 2. All right, let me show you where this is coming from. So I just showed you we have this identity. All right, let's make a new identity. We're going to divide everything up here by cosine squared theta. This is going to make us a new identity. All right, so let's simplify this with arithmetic. So we're going to get cosine squared theta over cosine squared theta is just 1, plus sine over cosine, we learned from the quotient identities, tangent, since it's squared, that's tangent squared theta. 1 over cosine is secant theta, and since it's squared, this is going to be secant squared theta. So that's a new identity. That's another Pythagorean identity. So remember that tangent squared and secant squared go together. And here again, we can change around the order to make different forms of this. So if I subtract my 1, all right, there's another form of that Pythagorean identity. Still same identity, just different order. I can subtract the tangent. Alright, so just three different forms of that identity. But the thing to remember here is that tangent and secant go together when they're squared. Alright, our third Pythagorean identity. Here again, let's start with the original one. Cosine theta plus sine squared theta equals 1. But then this time, instead of dividing by cosine, we're going to divide everything by sine squared theta. Alright, now simplify this. So cosine over sine, x over y is cotangent, since it's squared, cotangent squared theta. This is just going to be 1, sine squared theta over sine squared theta. And then 1 over sine is cosecant. And so we take the reciprocal, we're going to get cosecant squared theta. Alright, so there's our third identity. So let's look at the other forms. Here again, I can subtract my cosine squared theta and get cosecant squared theta minus cotangent squared theta. Alright, I can subtract the 1 and get cotangent squared theta equals cosecant squared theta minus 1. Alright, so three different forms of the same identity. Alright, now those are all the identities we're going to deal with this year. There are other identities, double angle, half angle identities that you'll talk about next year. Alright. Alright, how are we going to use these? We're going to be doing what we call verifying identities. It's sort of like proofs in geometry. Alright, so we're going to be working with one side of an equation only, and we're going to be simplifying it by using our identities, or not necessarily simplifying it, but changing, substituting in equal expressions to make it equal to the other side of our equation. Alright, so we're only going to work with one side only. Whatever one looks the most complicated, that's typically the one you're going to work on. Alright, look for opportunities to factor an expression, add fractions, square a binomial, create a monomial denominator, get a common denominator. So all the algebra that we've learned before are going to apply with these. We just got trig functions in there too. Alright, look for opportunities to use the fundamental theorems, the Pythagorean theorems, the reciprocals, the quotient theorems, or identities. Note which one functions are in the final expression you want. Sine and cosine pair up well, as do secant and tangents. And cotangents and cosecants pair up together. Alright, you may use a process similar to rationalizing the denominator. We're going to multiply by the conjugate. If something we want to get out of the denominator, sometimes we can multiply by a conjugate. We'll look at examples of all of these. And 5, if the preceding guidelines do not help, try converting all terms to sine and cosine. So when all else fails, change everything to sine and cosine and simplify from there. It says, do not just sit and stare at the problem. Try something. Even paths that lead to dead ends give you insight. So you guys, like I said, there's not a cookie cutter way of doing these problems. You kind of have to evaluate what you've got and kind of using these guidelines go through them. Alright, the key to verifying identities is the ability to use the fundamental identities and the rules of algebra to rewrite trigonometric expressions. So like I said, the hardest part about this is going to be the algebra, recognizing and how to use the algebra. There's no well-defined set of rules to follow in verifying trigonometric identities. The process is best learned by practice, and there may be more than one way to verify an identity. Alright, we're going to work on the following, verifying some identities. Alright, you probably want to do a separate sheet of paper. You need room, spread out. Don't kind of try to cram these all in a tiny space. So if you need to, pause the video and go get some paper. Alright, also make sure you've read these guidelines, that you understand these guidelines and read them at least 3 times. Alright, let's start. Let's verify some identities. Alright, so we're going to look at this. Alright, we're only going to be working on one side of the identity. So we're going to decide which side looks the most complicated. And hopefully you said the left side. So we're going to look at the left side. I want to make the left side equal to the right side. Alright, what can I do with this? I don't see any squares, so I'm not going to use my Pythagorean identities. I do see that secant, I've got a secant in there. Alright, and I want it to equal tangent. And I know that tangent is sine over cosine. So if I can get myself a cosine in this problem, then I'm headed in the right direction. Well, hopefully you remember that secant of x is the same thing as 1 over the cosine of x. So that's what identity I'm going to use. I'm going to use that reciprocal identities. All right, a lot of times, like I said, we tell you to draw a line down that equals because we're not going to cross that equals. Like I said, we're not solving an equation. We're trying to make the right side equal to the left side. Okay, so on my first step, I'm going to use my reciprocal identity and change secant of x to 1 over cosine of x. All right, and we can't skip any math in these steps. So I actually need to make that fraction. So sine of x over cosine of x is my next step. Well, by using the quotient identity, sine of x over cosine of x is tangent of x. And that's what I want. I want my two sides to be equal. Notice that I brought down this right-hand side and it equal to the bottom. Your left step should be where your left side is equal to your right side. All right, so there's my first identity. All right, let's try another one. All right, look at this one. All right, which side looks the most complicated? Probably the one with the fraction. Okay, like I said, there may be more than one way to do these problems. All right, so here again, I'm going to work on the left side. It's not always the left side, it just depends on the identity. So I'm going to draw a line through my equals again. I'm working on that left side only. Don't pick one side, stick with the one side. If you get stuck, then start over and try the other side. All right, so you notice that I have two expressions on my right-hand side. I only have one expression here, but I can use my algebra and break this into two expressions. So my first step is going to break this into two separate fractions. So here's algebra, just algebra. Okay. All right, now, sine over cosine is tangent, and that's what I want as part of my answer. So I'm going to use that quotient identity and change that to tangent minus, all right, 1 over cosine is secant, so I'm going to use my reciprocal identity and change that to secant of x. And there I've got what I want. Okay? All right, what if we'd worked on that other side? Let's see if we get the answer by working on the other side. So let's start over with our identity. Just want to show you that there's, like I said, more than one way to do these problems. So instead of working on my left side, I'm going to work on my right side. Okay. All right, so I see that I have sine and cosine and what I want, so I'm going to change these to sine and cosines. So tangent, I'm going to change into sine of x over cosine of x. And secant, I'm going to change into 1 over cosine of x. All right, notice I have a common fraction here, so that means I want to make this a common fraction. I already have a common denominator, so I'm going to keep my denominator and combine my numerators. And look, that's exactly what my left side is. So I've verified that identity. All right, two ways to do the same question. One's not more right than the other. Your whole goal is to, like I said, through the proper use of your identities and your algebra, make left side equal to the right side. All right, let's look at the next one. All right, I notice I've got sine squared and cosine squares in here. So that means I'm going to be using the trig identities to do this particular problem, because I've got squares in there. Trig identities, I mean the Pythagorean identities. All right, here again, I can choose either side, left or right. Okay, all right, I'm going to use the left side first, and I'll go through and do one with the right side too. All right, I know through the trig identities, I can rewrite sine squared x in terms of cosine, and that's what I want over here. I want this in terms of cosine. So I'm going to use my Pythagorean identity, one of the forms of my Pythagorean identity. So 1 minus 2 times 1 minus cosine squared x. All right, algebra, I'm going to distribute that negative 2. All right, combine like terms, so I get negative 1 plus 2 cosine squared x. All right, notice what I'm looking for, though. I'm not quite there. I need to change around this order. Use the commutative property. And now my right side matches my left side. It's always good to have symmetry. All right, what if we did the same thing and we did let's redo the problem and let's work on the right side now. Okay, so now this time I'm going to rewrite cosine in terms of sine. So I got 1 minus sine squared theta, or x, minus 1. Distribute again. Combine like terms. All right, well, order's not quite right, so let's use commutative property and change around the order. And now the right side matches the left side. It's always a good thing. All right, two different ways to do the same problem. Now, you don't have to do it one way, okay? So you don't have to do them both ways, but like I said, I just want to show you do have some choices here. Okay, let's look at the next one. All right, so which side is more complicated? Well, definitely the left side. All right, and this is only one where I'm only going to have to be able to work with the left side. There's nothing I can do to sine of theta to turn it into the left side. All right, so I'm going to be working at this right side only. All right, so now I don't have any squares in here, so I really can't change these to any of the Pythagorean identities. So, and it really doesn't do me any good. I can't break this thing up into two fractions because my common denominator is the sum of those two. So I'm going to go and change everything to sine and cosine. So secant becomes cosine of theta. Cotangent is cosine of theta over sine of theta. Plus tangent is sine theta over cosine theta. Okay, all right, we gotta get all this to simplify to just plain old sine theta. So I need to make this entire denominator here a single fraction. All right, so leave my numerator alone for a moment. Let's get a common denominator here. So my common denominator is going to be sine theta cosine theta, product of those two. All right, so what do I need to multiply this first one by? Well, I need a cosine. So I'm going to multiply the numerator here by cosine of theta, which makes cosine squared theta. All right, second part of this, what do I need? I need a sine, so I'm going to multiply by sine theta on the numerator. So this becomes sine squared theta. Unit 8 stuff. What we did back when we just got trig functions now. Okay. All right, hopefully, like I said, you recognize this to be the Pythagorean identity. So that's going to be equal to 1. So I'm going to have 1 over cosine theta all over 1 over sine theta cosine theta. All right, fraction. Like I said, just algebra. Let's flip and multiply. So we got 1 cosine theta times sine theta cosine theta. All right, simplify these fractions. So cosine theta into cosine theta gives me 1. And there I go. There's my sine theta. Notice I'm not skipping any steps. You can't just make the magically get to the answer. You're only allowed one algebraic change or one identity change per step. So you need to show all your work. So you can't just jump and say, oh, assume the person's going to get what you did. And like I said, you recognize the same kind of patterns of things are going to repeat the more that you do of these. All right, let's look at one more. All right, what side do you want to use? I would say the left side. I'm not sure we can do anything to that right side to make it equal to the left side. All right, so let's look at that left side. All right, I see that this is cubed. This is like having x cubed plus y cubed. We can factor that. We just got sines and cosines in it now. So I'm going to use my sum sap on this. All right, so instead of x's and y's, we're going to have sine and cosine. So it's going to be sine theta plus cosine theta times, give myself some more room here. All right, it's going to be sum sap, so I'm going to square, change the sign and multiply, and then square the last term, and it's always positive. All right, I'll put my equals over there to give myself some more room. I've got my square on my cosine. All right, so I just sum sap this. All right, all over sine theta plus cosine theta. Well, that's a common factor. All right? So that's going to just equal to 1. So that's going to leave me with sine squared theta minus sine theta cosine theta plus cosine squared theta. Well, you see on this right-hand side, I need a 1. So what can I do to get that 1? Well, hopefully you recognize you got sine squared theta plus cosine squared theta, which is equal to 1. So if I change around the order of this, here again using commutative property and grouping those two together, associative property, all right, I can use my Pythagorean identity and say that cosine squared theta plus sine squared theta is equal to 1 minus my sine theta cosine theta. And look, that's what I want. So now my left side matches my right side. Okay, like I said, if you have questions, please ask, and we'll do a couple more of these in class before you get started on your own.